So as we've covered in the previous videos, we showed that moving magnets create electricity and electricity creates magnets. So you can do a few other cool things with that. So you can see you can also create a motor that's a direct current that's swapping back and forth. So here we have an actual setup of a transformer, and you can see that if you put the electricity from the socket in there with 220 volts, it would blow up that little tiny bulb, and we've managed to reduce it down to 2 to 4 volts. And so how does a transformer work? So on the first one here, we have a step down transformer. You can think of it as a net. So if there's like a smaller net, then it's not going to catch as much of the current. So on the left-hand side, you'll see that there's an alternating current. So that's a moving current. So sort of if there's no movement, then it's not going to work. It's just going to stop. So the initial voltage is high, and that causes a magnet, and then the magnet carries through to the other side, and then that moving magnet, because it's alternating current, then creates the current on the other side. Now, because the net is small, it doesn't catch much of it, so therefore the voltage is decreased, but because there's conservation of energy, there is P equals IV, so the current is increased. So that'll be shown on the next slide. And on the right-hand side, we have a step-up transformer. So again, on the left-hand side, you have an alternating current going back and forth, creating a magnet. And so that magnet carries through to the other side, the right-hand side, going back and forth. And so the net is much bigger, so that catches a lot more of that field. So the voltage increases, and the downside is you can't move the net as easily through a body of water if it's larger, or the mesh is finer, and so the current is decreasing. So that's a little bit clearer when you see the transformer explained as a machine. So what you have here is a lever, and so if you're on the left-hand side, you can see the large red arrow means it's a large force, but it's over a short distance. And then the result on the other side of the lever is it moves a large distance, but the force is decreased. So it's a much thinner arrow, but it is over a larger distance. And vice versa on the right-hand side for a step-up transformer. So you have a large current and a small voltage, and on the other end, you have much larger force. You can lift something quite large, but only over a shorter distance. So large voltage, short current. So that's the P equals IV equation. So power also equals energy over time, and time's constant because these both happening at the same time. So that shows you the power on both sides are the same, just like energy on both sides are the same. So that's conservation of energy.